Our learning goal here is to be able to use technology to find or verify the key features of quadratic functions. The two technologies I'm going to use are Desmos and the Nspire software. So some of the things when we're talking about key features, and the things this video is going to focus on, are the zeros or the x-intercepts. So finding a zero or an x-intercept, finding a y-intercept, finding a turning point, determining the axis of symmetry, and we're going to look at the shape, the parabolic shape too, even though that's not a pointer, but it is a feature characteristic. So parabolic shape. So they're the things we'll focus on throughout the video. Using a Nspire, we turn it on and we choose add graphs, and we're going to enter a function here. There's the function entry line, you can see that. You can click tab to tab away from that or to that, or if it disappears you can use tab and it will enter something in there, or it'll open up so you can enter something in there, I should say. We're going to plot 2x squared plus 4x minus 3, so we enter that in there and press enter. We can see our graph. Now if we're going to go through those same things as zeros, a couple of ways of doing that. If you press menu and you go analyze graph, there's one straightforward way of doing that. You see all the features, so menu and analyze graph, and we can see there's a number of things there that might be quite useful. So we're going to look at firstly zeros. So what you do, you end up with that wavy line, you go either side, upper boundary, you see it's prompting you with questions down the bottom. It's identified the zero, just go a little bit either side basically and click, and you've got your zero there. Okay, and you can move text around. Okay, so there it is. So I'll repeat that if you like. So we go menu, analyze graph, 0, and negative 2.580, and we'll repeat it for the other one, either side, and voila. So we've got our two zeros. The turning point on this one is down here. Okay, now that's actually called a name, it's called a minimum. So if it's like that one, it's a minimum because the turning point is at the lowest point in the graph. If it, like some parabolas are shaped like that, so that would be called a maximum. So its turning point is at the top. So you either got a minimum or a maximum. So what else can we do? We can use the Nspire to find that. So if we click off our pen, go back to menu, analyze graph again, and we're going to choose minimum. And you do the same thing, you click either side. See, it's prompting you for question in the bottom left corner, lower boundary, bit to the left, bit to the right, and then kabang, you've got your point there, -1, -5. So that's pretty simple. If we go to the menu again, we'll find that analyze graph doesn't appear to have a y-intercept function. So what we can do is trace, and we can trace the graph. So that puts a little crosshair on there, and sometimes it lands in the right spot, and it did that time without me having to do anything. But a trace will move up and down the graph, and the point 0, -3 is the y-intercept, and you can click on that and you can see that it's telling me that. Okay, but the trace can move up and down and so on. So that's one way of doing that, and we can at this point too look at the axis of symmetry. So notice how this parabolic shape is symmetrical. Now if there was imaginary line, let me try and put one in. Alright, imaginary line going straight up, and I should have gone through -1 there on the x-axis. It's symmetrical about that. So the thing about that line, it's a vertical line. You might know from previous work that the x equal style lines are your vertical lines, but if you don't remember that, x always equals -1, so it's the line x equals -1 is the axis of symmetry there. Now let's switch over to Desmos. Now, while the TI is very powerful, Desmos is also one to consider as well to complement that. They each have their own strengths. So Desmos is good in that you can use it online, the web page that I'm using now, or you can get a phone or device app, which is a free app, and it works very well too. The good thing about Desmos is it's extremely easy and quick to use, and it's very intuitive. So you can see that I've entered in there. Get an account for Desmos too, that way you can save stuff, you can save all your files once you've logged in. So what we've got there is the same function, and basically it's an even simpler matter. All you need to do is click in the vicinity of the points you want, and you can see that if I, after the 2 zeros or the x-intercepts, if I click close to that, it tells me what they are, see? And if I do the same with the y-intercept, it tells me what that is, and it automatically assumes that you might be after those key points that we saw. It's very easy, isn't it? And the parabolic shape with the minimum is apparent here, and the axis of symmetry would be going straight up there. Perhaps we could even plot that in x equals -1, and we can show that there. So yeah, that's using technology to find key points.